Right, I wasn't going to do another example. I'm going to do one more, partly because the exercise I would have set is in your class textbooks, which are in college, and I don't have mine at home, so we are going to have to work from the online textbook. And just to make it clear how the questions are working, so we've got a smooth sphere S, it's moving on a smooth horizontal plane with the speed u, when it collides with a smooth fixed vertical wall. So in the questions in your online textbook, they've drawn it this way round, like that. But the wall is vertical coming out this way from the surface. So you can draw it this way if you prefer, I don't mind. I think I just prefer it this way because I'm used to it this way round. But draw it vertically if you want to. But it's coming this way out. I'm going to call that angle beta, and the thing we're trying to find is this speed, v. So u is the speed, it's coming down, v is the speed, it's leaving. If you want to write this as a vector, you would split it into its components and then write it as a 2D vector in terms of two perpendicular components, just to make that clear. I think I underlined those on a couple of previous examples, and yeah, they're kind of representing speeds really in this context. So at the instant of collision, S makes an angle alpha with the wall. Tan alpha is 3/4, and the coefficient of restitution is equal to 1/3. And we want to find the speed of S immediately after the collision. So we're looking to find what I've labelled as V. Labelling's up to you a bit. We're used to using U and V in this context. So we've just got to work with what we can. We can resolve parallel to the plane. Not to the plane, to the wall, to the surface. And we know that U cos alpha equals V cos beta. I'm not going to get V out as a number, it's going to be in terms of U because I don't have a number here. But unchanged, parallel to the wall. Perpendicular, we need to use coefficient of restitution. So E is equal to speed of separation over speed of approach, and we're dealing with speed here. I've written down the wrong thing, it should be a sign, sorry. So V sine beta over U sine alpha will give you E. Bringing that up, because I need to get to this tan alpha equals 3/4. E is 1/3, so 1/3 U sine alpha equals V sine beta, and I would personally times that through by 3. So that we have two simultaneous equations. This is actually quite similar to one of the other examples, except we don't have numbers in it. And I can now divide. So dividing 2 by 1 to create that tan. So U sine alpha over U cos alpha is tan alpha. And then 3V sine beta over V cos beta is going to give me 3 tan beta. Tan alpha is 3/4. And so tan beta is equal to 1/4. So we can actually use, you could use this one, or you could use this one to get to the velocity now, because you know that, I'll use this one here, but either or is fine. So if tan alpha is 3/4, you're in a 3, 4, 5 triangle, and so sine alpha is equal to 3/5. and tan beta equals 1/4. I'll pop that up there. So 1/4, that's root 17, and so sine of beta is equal to 1 over root 17. And so just plugging into this, 3/5 u is equal to 3 over root 17 v, and so v, the speed, is equal to root 17 u over 5. And then the next bit of the question is find the angle of deflection of S. So that is just alpha plus beta. Alpha from here, or from here, whichever you want. Alpha is arctan of 3/4. And then beta is arctan 1/4. And I don't have the answer. I mean, I don't have a calculator. Oh, I have. I've got a calculator here. So if I do shift tan of 3/4, and you'll find the questions tend to be in degrees because it's mechanics. I know we've been using a lot of radians in maths. And hopefully that'll give me a sensible answer. So 50.9 degrees. The angle of deflection. Lots of examples. I hope that's okay. I hope you're just getting a feel for it. And I'd like you to work through quite a few questions on these actually. So I need to find some from the book for you.